I've got 4 questions up on the board, and in a moment I'm going to ask you to pause the video and give these a try. The question is this a one-to-one function? And I just want to emphasize that even though I phrased that as one question, you really are asking 2 questions. First of all, is it a function? And then, if it's a function, is it one-to-one? If so, is it one-to-one? Okay. Because in order to be a one-to-one function, each x has to have a unique y. That's to be a function. Then in order to be a one-to-one function, each y has to also have a unique x. But the definition of one-to-one only applies to functions. So if you just check that second condition, but it wasn't a function, then the answer to this overall question is going to be no. Okay. So make sure you're checking both things. For the graphing ones, basically we're saying that to be a one-to-one function, it has to pass both the vertical and the horizontal line test. The vertical line test to be a function, the horizontal line test to be one-to-one. Okay, so give these a shot and then we'll go through them together. All right, with this first one here, if I just looked at do the y values have a unique x associated with them, each one does. 3 is a y value that's only associated with 1, and 5 only has the x value of 1 associated with it. But we're repeating an x value. This is not a function because that x value of 1 has 2 y values associated with it. So this one is no because it's not even a function. All right, for number 2, I gave you a graph, and it's just of 3 points. And, well, if I put the vertical line through each point, it's a different vertical line. So none of these points lie on the same vertical line. None of the points lie on the same horizontal line. So this is, yes, a one-to-one function. Okay. Now, for y equals the absolute value of x, I gave you an equation. So you could think about that algebraically, or you could think about that graphically, because that's an equation whose graph we know. Now, if I think about it algebraically, I can say, yes, it is a function, because I've been able to solve uniquely for y. But is it one-to-one? Will a y value have a unique x associated with it? And there the answer is no. Because if y was, let's say, 2, x could be either 2 or negative 2, because both of those numbers have the same absolute value. So I can see algebraically no, because it's not one-to-one. Now if I looked at the graph, I know that the absolute value function gives me this v. Now it is a function. It passes the vertical line test, but it fails the horizontal line test. Okay. So this is no, because it's not one-to-one, but it is a function. Okay. Now 4, I gave you a graph. It's not a function. Fails the vertical line test. Okay. What's interesting is it does pass the horizontal line test. So if you see the words one-to-one and you only check the horizontal line test, you might say, yeah, that's a one-to-one function when it's not even a function. Okay. So the answer here is no, not a function. Now, it could be that there's a question where they say, here's a function. Is it one-to-one? If you're told it's a function, so that you already know that it passes the vertical line test and each x has a unique y associated with it, then you only need to check the horizontal line test and do the y's have a unique x. But if the question is this a one-to-one function? That is a 2-part question. You need to check to see whether it's a function, and then you need to check to see whether it also is a one-to-one function. Again, the words one-to-one, we don't apply to something like this. I would not say this is one-to-one, but it's not a function. I would say this is not a one-to-one function, because it's not even a function. So one-to-one is an adjective that describes functions. If it's not a function, it can't possibly be a one-to-one function.